All right, everybody. Welcome to the 2025 coach training for the Rock Hound Science Olympiad event. This is the Igneous Rock edition. I am your event supervisor for this year. My name is Dominic Aluya, and this is my first year as a Science Olympiad event supervisor. We have a good bit of ground to cover for our presentation today, so I thought it'd be good to stick to a loose agenda here. So we'll do a brief introduction and then kind of get into more of the meat and potatoes as far as like what to expect from the event. We'll kind of move into my tips for how to build your team's chart, or as I would usually call it, a cheat sheet. Tips for how to build your team and advice for how to be successful in the event. And we'll wrap up by showing some resources that we have online on our website and some external resources to make sure that your students are well prepared for any question I could possibly ask. So kind of getting into the introduction. So for a bit about me, like I said, my name is Dominic Aluya. I am a geologist. I work for the state of Michigan with the Department of Environment, Great Lakes, and Energy. I'm proud to say that I'm also a Utica Community Schools and Science Olympiad alum. I participated in this event as a Science Olympian in the elementary, middle school, and high school level when I was at Messmore, Mallow, and Eisenhower. So I'm really excited to be here. It's very interesting being on the side of the test maker instead of the test taker. So just I would guess it'd be helpful for me to get a feel for a bit about you all. So just by a quick show of hands, would you be able to show me if it's your first time coaching this event this year? Okay. So we have a good mix of rookies and veterans. That's good. I hope that this presentation has some good information for the returning coaches and is enough to bring our new coaches up to speed so we all can be successful this year. So kind of getting into what the event will entail. The rules that I created are available on the Macomb Science Olympiad website. This test will be completed on a zip grade form. I provided an example here. It's just like a simple Scantron form. So students will have to bubble in their answers as they work through the event. The event will run for about 30 minutes. And students, like I said, may bring in one 8.5 by 11 chart or cheat sheet with them to help them with the event. This year's focus is on igneous rocks, and I'll probably say this a couple times throughout the presentation, but the teams will be required only to identify the rocks and minerals listed on the rules. There may be some bigger picture topics or bigger picture items about each mineral that are shared with minerals not on the list that I could ask about, but they will only be asked to identify specifically the rocks and minerals on the list. And I'm realizing now I still see some hands up. So if you do have any questions as I'm going, feel free to type them in the chat and I'll do my best to get them at the end. Anything I can't answer, I'll probably be able to either add through the FAQs, or if there's a more complex question, I'll probably try to add some information on the website just so it's publicly available for everybody. So moving on. As far as what the actual test will look like, this will be pretty consistent from when I took the event way back in the day. I plan to write a test of about 20 stations. Each station will consist of a box with several samples inside and questions on the underside of the lid of the box. So there'll be about 1 minute allowed for each station to answer between 4 and 6 multiple choice or true and false type questions that'll be worth between about 1 or 5 points. It's really hard to give a general idea of what type of question will be worth greater or fewer points, but point values generally will vary depending on the question difficulty. And what's really important is the students are allowed to handle the samples. I think it's really important and fun to just be able to pick up all these rocks and look at them and be able to see all the physical properties that they'll end up using to identify them. Only in situations where I specify do not pick up the rocks will they not be able to pick up the rocks. And something I did want to note too, because this definitely got me a couple times when I did this event, some stations will not have samples in the box. It doesn't mean it's a free space. There may be some questions that they still need to answer that are just may not have minerals or rocks attached to them. So make sure that you remind your students to open the lid and read carefully to make sure they aren't missing anything. And then on the big day, something that really helps the event move smoothly. It's a timed event, 1 minute per station, 30-minute block is all I have. So it's really important that your students promptly close the lids of their boxes when I would say to close them so they can move to the next station and then wait for me to give the instruction to open before peeking. So no sneak peeks allowed. Yeah. And then kind of getting into like what they'll actually be asked about. So which specimens? So the rocks and minerals that the teams will need to be able to answer about questions about are identified in the rules. Like I said previously, I will only ask them to identify the rocks that are listed. But some of those rocks do share properties with other minerals that aren't on the rules list. So an example off the top of my head would be like if you're talking about a crystal shape. We're all familiar with like halite or table salt. It has those little cubic crystals. Other minerals like galena or lead also show those. So it would be reasonable to say, like, if I show a picture of lead with like those cubic crystals, for them to know what a cubic crystal shape is. But kind of moving on, again, this year's focuses on igneous rocks. I would make sure that you are referencing the current year's rules. I did see on the website that historic year's rules are available. It's important to make sure you're checking this year's rules because the rocks and minerals are slightly different. To cover this year's igneous focus, 3 new rocks and 2 new minerals have been added to the rotation. Those rocks are diorite, gabbro, and rhyolite, and the minerals are hornblende and olivine. I believe, I'll have to double check, I think that these rocks and minerals are underlined and bolded on the rules too, just to make sure that they stand out. And I just wanted to say too, although the focus is on these igneous rocks and associated minerals, I would not put an emphasis on them to the exclusion of the other rocks and minerals. There may be a couple additional questions or maybe 1 or 2 other stations that cover these rocks, but they will be still expected to understand and have a comprehension of the other remaining items on the rules as well. So kind of getting into the kinds of questions I would ask. So rock characteristic questions may be about their color, texture, uses, physical characteristics, special properties like their reaction to 3 molar hydrochloric acid, and environments of formation. Each category of rock, sedimentary, metamorphic, or igneous, has its own term to kind of describe the texture that that rock would exhibit. So for an example with igneous rocks, if you have a igneous rock like basalt, that has small uniform grains, and you would describe that texture as being aphanitic. Rocks with large grains, by contrast, like granite you might see at one of your countertops, that texture is called phaneritic. Other things that would be important to know are things like special properties. Like these are things that can refer to a rock's reaction to acid, whether that rock fluoresces with UV light, or its solubility in solutions. Another thing that I'd say can come up oftentimes in these sorts of exams would be things about or particular interest about the rock, such as like unique uses or standout properties. Some that come to mind again would be like the use of quartz in wristwatches, or scoria as a common landscaping rock. That's that like red vesicular rock you may have at some of your homes. Going on further, when I talk about environments of formation, that kind of refers to the physical circumstances that lead to the formation of each kind of rock. And generally speaking, a lot of this, if it seems like a lot of information, like I understand, there are existing rock workshop PowerPoints online that I'll reference again later that give a more detailed overview of these rock characteristics. But one that I wanted to touch, go into a bit more depth on, is actually the environments of formation. So the students would be expected to have a general idea of where these rocks would form and how and what sort of environments they form in. So when it comes to igneous rocks, where they would likely to be found relative to continental plates or hotspots. When it comes to sedimentary rocks, whether those rocks would typically form in a wet environment like a beach, river, or lake, or be deposited by the wind in a dry environment like a sand dune. And with sedimentary rocks, also considering like which grain size or shape would typically be encountered in each environment. When it comes to metamorphic rocks, kinds of questions relating to the type of metamorphism, whether it's contact or regional, and also having an understanding of the precursor rocks or index minerals that are the parent rocks to the metamorphic rocks that we see after they undergo that heat and pressure. And finally, when it comes to environments of formation of minerals, things to think about would be whether or not they're evaporates, like they precipitate out of a solution, like halite or gypsum, whether they could be found at hydrothermal vents, like copper, or if any rocks and minerals would be associated with volcanism, which tends to be a lot of rocks. The students will also need to have a good understanding of the rock cycle. The rock cycle encompasses the processes of formation of igneous rocks, like whether they're intrusive or volcanic glass. They would need to be familiar with the processes of sedimentary rock formation, like erosion, deposition, and then over time, the compaction and lithification of those sediments into the sedimentary rocks themselves. And they'll also need to be familiar with the processes of the formation of metamorphic rocks, like the effects of heat and pressure on those existing rocks. Your students should also be comfortable identifying the steps of the rock cycle and associated rocks and minerals with each step and process. So just to give kind of an idea, I provided 2 examples of the rock cycle. There unfortunately isn't one default rock cycle I can show, but generally, with any rock cycle, you'll see, beginning with, I guess because that's igneous rock focus, if we start with magma, all rocks begin as igneous rocks where they cool from magma. Those igneous rocks over time, like tremendous amounts of time, are weathered, eroded into sediments. Those sediments are compacted into sedimentary rocks. And over tremendous periods of geologic time and being buried by other sedimentary rocks, those rocks undergo heat and pressure, transform into metamorphic rocks. And then over even longer periods of geologic time, as those tectonic plates move, those metamorphic rocks may be subducted and form magma and starting the process all over again. But something with this slide that I really did want to emphasize is while this chart on the left generally shows it as being a cyclical process, this one on the right kind of shows how each rock type can transition into the other one. So for instance, any of these rock types, sedimentary, metamorphic, or igneous, can undergo weathering and erosion to create sediments that would create more sedimentary rocks. Any of the rock types, whether it's igneous, sedimentary, or metamorphic, can melt to form new magma to create igneous rocks. And any of the 3 can undergo heat and pressure to create metamorphic rocks. So on one hand, any of these processes of weathering and erosion, deposition and compaction, and heat and pressure can happen to any rock type. But then kind of to get into the star of the show for this year, we'll talk a bit about the igneous rock focus. So I plan to include some special questions relating to this year's igneous rocks. These can be questions like relating to the grain size and texture, like I talked about earlier, when you have, like, for instance, small grains as an aphanitic texture versus large grained rocks having a phaneritic texture. I'll also probably ask some questions about types of igneous rock formations and associated rocks. And that's kind of shown with this chart on the right. In the rules, I would have identified it as with rock formations, including like batholiths, volcanic necks, dikes, and sills. It would be important to know that, for instance, batholiths would be more of your intrusive igneous rocks because they form below the subsurface, while your volcanic neck and lava flows, things like that, would be considered extrusive rock formations because they form above the Earth's surface. And then what is also new to this year is what's called Bowen's reaction series. Bowen's reaction series is a handy chart, I think, that really summarizes a lot of the factors of formations of igneous rock, including the temperature of formation, mineral composition, and density. So I'll go into a bit more detail right here. So it may seem like a lot of information, and it is, but this is, in a sense, why igneous rocks are the way that they are. It's all summarized in this chart. So what this chart tells us is the order that igneous rocks will form from a magma as that magma cools. In a nutshell, that's it. So, but the kind of questions that you can ask a lot of questions about this too, and it really does a lot to show why igneous rocks are the way that they are. So for instance, something that the students will need to understand is that, like for instance, basaltic rocks are considered mafic rocks. Mafic rocks are calcium rich. And if you pick up a piece of basalt, you'll notice that it's a lot denser than granite. Like it will feel heavier if you have the same size of rock. And it makes sense because the heavier, larger calcium atoms want to leave that liquid magma faster than the lighter sodium. So as it cools, you'll get the basalt first as you take away all this calcium, but then once all the calcium's out of the solution, then you'll enter into more of the sodium-rich andesites, diorites, rhyolites, and granites. So I will not be asking them specifically to tell me like chemical formulas of these rocks, but just understanding that, for instance, like basalt is mafic, it has more calcium. Andesite is felsic, and that has more sodium, would be something that they should be expected to know. And why I really like Bowen's reaction series is it does tie into a lot of the other topics that I previously talked about, like when it comes to grain size and texture, environments of formation, and mineral composition. Like this shows that as your magma cools, you would expect to see like olivine as more of a mafic mineral. You would expect to see quartz in your granites. Like that's something that could come from this chart. But with this, there are two things I wanted to edit. This is the best example that I could find. Amphibole is not a mineral that they would be expected to know. You can basically swap that out for hornblende. Like that is a mineral that is on the rules that they would need to know. And then the other one is potassium feldspar. That is your pink feldspar in the rules. So if you were to pull a different example of Bowen's reaction series that includes amphibole or potassium feldspar, this is what you should interpret that as instead, hornblende and pink feldspar. And then finally, kind of getting into the mineral characteristic questions. Mineral characteristic questions could be about their chemical class, color, luster, density, relative hardness, reaction to 3 molar hydrochloric acid, the crystal shape, the crystal's texture, its cleavage, its fracture, and any sort of other special properties like its conductivity, its fluorescence, optical properties, and reaction to flame. When I say reaction to flame, think the color if the mineral is burned. Other things I could ask about are also the mineral's uses and environments of formation. I did want to call it a couple quick things though. I may ask, like if an example of a native mineral, this would be one that's composed of just one element. So there are 2 on our rules list. Those are copper and graphite. And when it comes to chemical class and for our purposes just refers to the anion, which is the negatively charged ion at the end of the chemical formula of the mineral. So for example, the sulfide mineral class, they all share the same sulfur ion S2- at the end of the formula. So for instance, pyrite is an iron sulfide mineral. The students would not need to know the chemical formula like I just spelled out there, FeSO2. They would just need to know that pyrite is a sulfide mineral. So that was a lot of information. Thankfully, your students will be able to prepare a cheat sheet or a chart to bring in. They can bring in one double-sided chart that measures 8.5 by 11. Nothing else can be brought into the testing room though. So I wanted to share a couple of pointers as far as making the chart. I would really recommend putting information that can't easily be memorized. So kind of things like the mineral's hardness number, the density of the mineral, and any shared rock and mineral characteristics that you think would be kind of tricky when distinguishing one rock from another. Something I would really highly recommend is the team making the chart for themselves, or at least putting as much effort as they can themselves into it. If they do it themselves, it's almost like a practice exercise in and of itself because they'll be familiar with the information that they add to the chart. And because they created it themselves, by default, they'd be more familiar with it. So they'd be more easily able to get to the information they need when they're in that timed testing environment. Something else that I kind of recommend is to figure out early on which team member was more comfortable with handling the chart and which team member is more comfortable with filling in the question bubbles too. It would be kind of chaotic to figure that out the day of. And then that kind of leads into some general tips I would have. Speaking as a participant in this event, I would highly recommend starting early. There's a lot of information that I could ask about the listed rocks and minerals. So starting early and getting more familiar with it would be best. I would also highly recommend playing to each individual's strength. There were some years when I did this event that I would be more focused on the rocks over the minerals, and my partner would pick up whatever I didn't do. So asking the kids like, hey, like, what do you think is more interesting, the rocks or minerals? Or after exposing them to some of them, that might be something to think about too. Um, and I've kind of used a good bit of rock jargon throughout this presentation. I would really pay attention to, or really emphasize that the students understand what the vocabulary means. So for instance, I've used the word mafic a couple of times. It's one thing to understand that basalt is a mafic rock, but something that they should understand is what a mafic rock is. So like, because basalt is mafic, that means that it has certain properties. So really having a good understanding of the vocabulary. I'd also highly recommend, if possible, to get some physical samples. I'll put in a plug to purchase the rock kits that we offer. Those do contain samples of the rocks and minerals that the students will expect to see in some of the test bins on test day. I'd also recommend, as you move on and get a better idea of what, as your students get a better comprehension of the rocks and minerals, to begin doing some practice tests. Test often and time those tests. 1 minute may seem like a good bit of time, but if you're really weighing between one or two options, it's crazy how fast that timer can go down. I'd also recommend I try to make some games out of it. And something that really helped me and other friends of mine is to make flashcards. If you haven't heard of it, there's a website called Quizlet. It's a really good online flashcard resource. They would be able to make their own flashcards there, or there's already hundreds or maybe even thousands of existing rock and mineral and geology flashcard sets that exist that they would be able to reference for extra study material. So on the big day, some competition strategies that I would have are to not waste time arguing. Like I said earlier, 1 minute can go by so fast, especially if your students are wavering between one mineral identification or another. I would really highly recommend trying to go ahead and answer whatever questions they can, and then going back and discussing the ones that they may have disagreements with. Something that also comes into play too, even from when I did this, is to match the question number to the zip grade form. So I'll probably letter the questions or the stations like alphabetically A, B, C, D. When they open the lid and see a question number, they'll have to make sure that they match that question number to the zip grade form. So if they open a box and it starts at 20 and it's their first station, they need to make sure they start bubbling in at 20, not 1. That would cause quite a headache later on for us to sort out. And I guess that kind of brings it to a close. So some resources I wanted to point out. I would check with your school to see if they have any materials from previous years. There are previous workshop PowerPoints and recordings available on the website. Some particular ones I would recommend would be to check out the 2024 Coaches Workshop and the existing igneous, metamorphic, sedimentary, and mineral PowerPoints. The previous event supervisor, Judith, did a tremendous job kind of breaking down what each of those rock and mineral characteristics are and providing examples. So that's a really, really good starting point. I did see floating in, someone asked a question about previous tests. There are some older tests available online. The most recent is from 2015, but I can assure you as a geologist, not a whole lot has changed over the last 10 years with how we describe some of these rocks. They've kind of been pretty consistent for a good chunk of time now. But then some other resources I would recommend. I did check these out. It's geology.com, galleries.com, and geologyscience.com. These websites have a lot of good photos of the minerals and rocks that they'll be expected to see and identify. And they also break down a lot about the rock properties, uses, mineral classes, and environments of formation. So these 3 websites, plus a really quick plug for the National Audubon Society Rocks and Minerals Field Book. Anything that I would ask about as far as rocks and minerals should be encompassed by these resources. So it'd be a really, really good place to start. And with that, I'll be able to take some questions, but thanks so much for joining for the Rock Hound Coaches Workshop. I'm looking forward to this year. So
as you see, Dominic, there are a number of questions that have popped up in the meeting chat.
Yes.
So if we can go back to the beginning of that, I've answered a few of them that were easy process, but a few of them I have not answered.
Yes. Okay. So looking Oh, go ahead.
In fact, I'll take the first one. So there was the comment about the fact that galena is not on the mineral learning list. Um, in recent years, we found that rock companies are not willing to supply us samples for that because of its lead content. And so that's why it disappeared. In past years, galena was in scope, but I'm fairly certain it's no longer in scope.
So I would like to add quickly. So when I would not add, when I would give that example about cubic crystals, I would not show a picture of galena and ask them to identify what galena is. But because there are other minerals that they would be expected to identify that share properties with galena, a type of question I could ask is, looking at this picture of a rock, what type of crystal shape does it have? But I would only ask a question like that if I know and am confident there's a rock that they would be expected to identify that has that property. Does that make sense? I hope that answers that question. Let's see. So galena. Will the information be updated on the website too? Yes.
And as you provide me information, we try to get it up within a day or two. So in general.
Yes.
Yeah.
All resources that, oh, you answered that. I see that now. The question from Lynn. I looked this morning and it's still showing 2024 igneous rock and minerals.
We have not taken down materials from previous years.
Right.
And especially for, as you noted, for this event, things haven't changed in geology a lot.
Yeah.
And so there's a lot of the resources that were created and provided in previous years are still great resources. So there will be some things that will update, and there'll be some things that stick around for a long time.
Mm-hmm. Let's see. Someone asked, do I need the chemical class for the entire list? Yes, I think it would be important to know just of the minerals, because there are no chemical classes for rocks. So for the minerals listed, it would be important to know what mineral class those minerals belong to. Yes. I see a question 3 years ago, when igneous was the focus, would students need to know the 3 types of volcanoes? No, I did not put that on the rules. I thought that focusing more on Bowen's reaction series would be a better job of kind of piecing together why igneous rocks are the way that they are. So they would not need knowledge of volcano types. Sample questions. Yep, there are several tests that are posted, with the most recent being from 2015.
From a rock kit standpoint, Macomb Science Olympiad does sell a rock kit. And so if it's categorically one of our quick start kits, and that rock kit has been specifically, the scope of it specifically matches our rules, and it does match. It's a rock kit which is inclusive of the scope of rocks that would appear in all 3 categories of your event: metamorphic, sedimentary, and igneous. So last year's rock kit works. There are some specimens in it that are not part of the focus of the current year because of that rotation.
Mm-hmm. So I think that kind of answers the next question. And then following up with the like kind of a deep dive. So this year, with it being my first year as a supervisor, I will not be putting on that in-depth coaches workshop. That's why I really highly recommend checking the previous online resources. And again, highly recommending checking out the external websites that I posted too, just so that your students will be able to see a lot more photos of the rocks and minerals to supplement whatever physical samples they're able to get their hands on with the rock kits. And this presentation will be posted, but there will not be that workshop in February. So I think that's it.
I see a question here about how does my daughter find out her partner? So if you have questions about who's on your team, your head coach for your each school's team has a head coach, and that's the person you should be talking to.
All right. Well, I think that kind of takes up the questions for today. I don't have anything else to share, so I'd say good luck to everybody. If you do have other questions, the FAQs are available. Yeah, so good luck to everybody.